For this video, we're going to introduce the idea of functions and review some concepts that hopefully you remember from previous courses. So a function is just a relationship between two variables where one variable determines the other variable. And what you see below, f of x equals y, that's how you say that mathematical sentence. And that is known as our function notation. So f is the name of the function. X is your independent variable. Known as our input. And y is the dependent variable. Known as the output. And what's really important about a function and what makes something a function is that each input can have only one output. If it has more than one output, it is not considered a function. So functions are rules that convert inputs, which we typically know as x values, into outputs, which we typically know as y values. So it makes sense that they must have their own notation to indicate what the rule is, what the input is, and what the output is. So here is just another example of function notation. Remember that the x is your input, f of x is your output. It's the same as y. And then whatever comes after the equal sign is known as our rule. And that's what you're going to follow in order to evaluate. So just to talk about some function notation, we're going to use this example here. Let P of t represent the number of people in a store t hours after the store opens at 6 a.m. So for this particular part, this is my input or my domain, which we'll start talking about eventually. So we want to interpret each of the following statements in context. So in this case, for A, P of 2 equals 83. So this means that T equals 2. T is the number of hours after 6 a.m. So that means at 8 a.m., there are 83 people in the store. Because P of T, the number of people in the store, that's the output. Okay, so at 8 a.m., there are 83 people in the store. B, P of L equals 121. So this time they're not giving me a value, that's okay. So this just means L hours after the store opens, whatever that is determined to be, there are 121 people in the store. And then C, P of 3 equals P of 6. So P of 3, that's T equals 3, which is 9 a.m. P of 6 is T equals 6, which is at noon or 12 p.m., whichever you'd like to write, and they're equal to each other. So there are the same number of people in the store at 9 a.m. and at noon. So that's how we use function notation to interpret things or represent things in context or in real life. So evaluating functions, we can evaluate functions multiple ways. Right now we're going to look at algebraically, so that means with math. So given the function f of x equals 3x plus 7, we're going to evaluate f of 2. So remember that 2 is my x value. So that means anywhere I see an x, I'm going to substitute a 2. So if I'm doing this by hand, 3 times 2 is 6, plus 7. That means f of 2 equals 13. So f of 2, remember, is my y value. If I were to write this as a coordinate point, x comma y, it would be the point 2 comma 13. So just taking a look at 2 additional practice problems here. F of x equals 2x plus 5. Find f of negative 3. It's especially important with negatives that we substitute with our parentheses. So 2 times negative 3 gives us negative 6 plus 5. F of negative 3 is equal to negative 1. And then number 2, if g of x is 2x squared minus 3x plus 8, find g of negative 1. I'm going to substitute negative 1 everywhere that I see an x. And for this one, we're going to just practice using our calculator. So in the home screen of my calculator, I'm going to clear out anything that I have. 2, open parentheses, negative 1, close parentheses squared, oops, minus 3, open parentheses, negative 1, close, plus 8. So g of negative 1 is 13. And like I said, you can evaluate functions different ways. This was algebraically, and then the last part of this video is to look at it graphically. So it's important to remember that inputs are x values, outputs are y values. So in example A, I'm looking for f of negative 1. So this means f of positive 1. X is positive 1. I want to know what is y. So I'm going to go to my graph. This is 1 on the x's. I can even draw a straight line through it if I want to. So this is the point 1 comma 4, which means f of 1 is 4. Next, I'm going to f of negative 3. So if I look at negative 3, here's negative 3. It hits my graph here. This is the point, negative 3, negative 4. So f of negative 3 is negative 4. And then lastly, f of negative 1, that's right here. If I draw my straight line, it occurs on the graph right there. This is the point negative 1, 0. So f of negative 1 is 0. So that is your review of function notation, evaluating functions, interpreting functions, and you have a few problems to try on your own.